Hey everyone. So let's take a look at section 12.4 and example number 4 or question number 4. So let's take a look at how to solve an example like this. So as you can see, this one is talking about, is there a significant correlation between household income and the size which a child will draw a nickel? So basically, are we saying if there's a higher household income, will the drawing of the nickel by a child be larger? If the income is lower, will the drawing of a nickel be smaller? Uh, so that's kind of the general idea here. So household incomes in thousands of dollars are shown for each of the 75 samples below, along with the size of a nickel drawn by the child. So you can see we have this table over here with 75 samples. So we've got household income for 75 homes and the coin size that a child would draw in millimeters. So the first thing you will see here as you go scroll down, we're saying test the claim that there is significant correlation at the 0.01 significance level using a linear regression t-test for the slope. Retain at least 3 decimal places for all values. So the first thing we have to do is identify the correct hypothesis. So you can see we're using the rho variable here. We're using mu, the p-value, rho again, and r value. So at this point, I would direct you guys to your textbook. And again, this is from section 12.4. So you will see it's not a very big section. I think you guys can do a quick read through, and that would really help you guys out. But basically, you can see they define the rho variable for us, and you can see the rho is defined as the population correlation coefficient. And that's what we're talking about because we want to know, is there a correlation between the household income and the size of the nickel, a child will draw? So this is going to be a rho variable that you will be using. Now, you can see there are two different options using the rho. So you need to choose between, is it going to be rho not equal to 0 for the null hypothesis? And then for the alternative hypothesis, is it rho equal to 0? Or for the null hypothesis, should it be rho equals 0 and the alternative hypothesis being rho not equal to 0? And you guys have done hypothesis testings in chapter 9, so you should be familiar with this. But again, when in doubt, come and take a look at your textbook over here and you will see how we are setting up our hypothesis test. So your null hypothesis is rho equal to 0, alternate hypothesis is rho not equal to 0. So of course, we'll go ahead and select that. Now I am in teacher mode. Student mode looks a little bit different, but I think it does not matter because you can see how we need to go about performing these calculations. Now, once you select your hypotheses, then they are asking you to do a t-statistics value. And, again, you've got your textbook over here and they'll kind of walk you through on how you need to do the process here. So you will see that they do talk about using a handheld calculator and they're telling you which test you can use. Now, if you guys have a calculator that you want to use, that will be fine. But I actually prefer using Google Sheets, or you can also use Excel. So I found a similar test to this one for, Google and Excel. So the function will work in both. And it is actually called the line ST, or however you want to say that, LINEST. This is the function we will be using to help us out. So what you're going to do, and I've put the functions here so you guys can kind of see what this looks like. If it helps, I can kind of make my screen a little bit bigger. Maybe that's too big. But anyway, you can see what those functions will be. So you want to start out with equal to, and I'm just going to start typing that function, and then you can see it pops up here. So we're using that line ST function, and you can see your first argument is going to be the known data Y values, which is obviously going to be your second column over here, the coin size. So I'm going to select all 75 of those value. So I start at the top and I keep going till I get to the bottom of my column, my table. So I'm going to hit comma. So that tells Google Sheets that I'm done with the first argument. For the second argument, you will see we need to use the X value. So the known data X, which is going to be our household income. So now I'm going to select all 75 of those values. So you can see I go down to the bottom. And then for the last two arguments, you can see we just need to type in true and true for both of those. So what did I do? So true for the first argument, true for the second argument. And of course, if you want to see what those arguments are, you can always go and take a look. So that's going to be for calculating your y-intercept, and then your verbose, which you can kind of see the description for that over here. But again, we just need to put true and true for those last two arguments. And then you will see once I hit enter, it actually spits out quite a few values over here. Now, we're actually not interested in all of them for this example. We are just interested in the first two rows. So that would be these two rows. And honestly, even in that, we're only interested in these two numbers over here. So this little value over here is going to represent the slope. Oh, sorry, wrong place. So this here is going to represent the slope of the line. And this one here is going to represent the standard error based on the slope. So this is going to be the standard error of the slope. So you can kind of see what those values come out to be. Now you will see that for the t-statistic value, again, that's the second line over here, we need to take our p-value. Okay, there we go. So for the t-value, we are going to take the slope that we just calculated, which is going to be that negative 0.0696 number, and we're going to divide it by the standard error. So our standard error here is going to be the 0.0216. And you can see this is what our t-statistic value will come out to be. So I'm just going to do a copy from here, come back to my homework problem, and I'm going to do a Control-V to paste it. Now you will see they did ask us to round all of these to 3 decimal places. So I'm going to go down to 4 decimal places. I see that my 4th decimal value is a 2, so I can delete that. And that's going to be my t-statistic. All right, so we've got our t-statistic value here. Now the next thing we have to do is calculate the p-value. So for the p-value, which is actually what this function here is going to help us, is going to be the t.distribution.2t function that we need to use. So let's go ahead and do that. So this is where we calculate the p-value. And again, you start with equal to t.distribution. And we're, of course, going to the two-tailed portion of the t-distribution, right? Because this is a, remember your null hypothesis was, sorry, your alternative hypothesis was rho not equal to 0. So that's why you're doing the two-tailed test here. So we're going to do the 2t version. And then since your t-statistic is a negative value in the function, it needs to be a positive value. So you will see we're using the absolute value function. So we're going to take the absolute value of our t-statistics. And again, I just click on the cell because I don't want to round the answers too early. So anytime I do my calculations, you will see, again, when I did the t-statistic calculation, I just clicked on these cells. That's the same thing I'm doing right now for the p-values. I'm just clicking on the cell itself instead of typing the numbers in. So we've got the absolute value of our t-statistic calculation. And then you can see your second argument is going to be the degrees of freedom. So remember, your degrees of freedom is the n-2 value. In this case, n was 75. So it's going to be 75 minus 2. And then again, we close our parentheses. And as soon as you hit enter, it will give us our p-value over here. So we've got the p-value. Again, I'm going to copy this and then paste it to our homework problem. Again, I'm going to take this down to 4 decimal places. And you will see I have a 9 in my fourth decimal place, which means my third decimal place will go up. So the 1 will actually become a 2 when I do my rounding. So now we have our t-statistic. Based on the t-statistics, we calculated the p-value. But then, based on that, how do we know if we need to reject the null hypothesis or do not reject it? And again, come back to your textbook for that, because you will see here, they're telling us if the p-value is less than the significance level, which is your alpha, that is when we decide to reject the null hypothesis. So remember, right here underneath the table, they gave you the significance level, which was 0.01. So now you need to see, is 0.002 less than 0.1? And then based on that, you can go ahead and come up with your rejection, or what you need to do in terms of your testing, right? So I'm gonna let you guys figure that out, and then decide based on that, and then I'll show you how to do the regression equation over here, and then you guys can kind of put in your own conclusion. All right, guys, so for the linear or the regression equation, sorry, it may not necessarily be linear, but for the regression equation, we actually come back to this calculation that we did here. And sorry, I kind of rearranged my Google Sheets a little to make it look a little bit more neater and make more sense. So anyways, we actually come back to that first line again, where we had the slope for the, where we calculated our t-statistic. But basically, these are the two cells that we will need for completing our linear regression. Again, sorry, not linear, our regression equation. So basically, your equation will be in the form of y equals mx plus b, which of course is a linear equation, as you will see. But I'm sure if you were to try and graph this, excuse me, you may see that it's not exactly linear, but that's how scatter plots work, right? That's how linear regression works. You may be anywhere between -1 to +1 correlation coefficient value, right? So that's kind of what this is based on, which is what you guys did in the first half of this chapter 12 anyway. So our slope is going to be this value over here. So again, I'm just going to do a copy paste over here. So you can see our m value is going to be this. And, of course, we do mx. So that means you're going to be multiplying this with x. Plus, for the b value, we'll be using the second cell over here. So that's going to be the 24.161. And, it kind of goes on. So you can see this is what your linear regression equation will look like. And we base this on x because they are telling us that this regression equation needs to be in terms of x. So you already have the y value in there. You do not need to type that. So you just start with the m value. Don't forget to put that negative sign, because obviously that tells you that there's a negative correlation between our x and y variables. Now, they did tell us to round this to 3 decimal places again. So obviously make sure you do that. So this should be 1, 2, 3, 4. So yeah, you can see this guy will basically go up to 70, and then this one is 161, and there's a 0 after it, so we can get rid of all those other decimals after that. And then again, you will need to select your prediction for part G to predict what diameter a child would draw a nickel given the family income. It would be most appropriate to use which one of these. So I'm just going to submit this this problem. And of course, I did not get full 100% grade on this, because remember, I left some of those answers blank because I want you guys to do that. So I did show you the hypothesis testing, but again, that was available in your textbook. You can see the calculations that we typed in came out correct. You guys need to select what the rejection or not to reject the null hypothesis, what conclusion based on that you will need to come up with, and then what does your regression equation look like, and then how would you make your prediction. And again, I want to point you again to the textbook because you can see it tells you if the p-value is less than the significance level. If the p-value is not less than the significance level, what decision do you need to make and what conclusion can you base on top of that? So you can see that will help you answer parts D and E. And then this should be pretty straightforward, but again, you can come and look at your textbook to try and determine which one of those calculations would make sense to make the prediction. And I'm really hoping that that is something you guys can kind of figure out on your own. So yeah, so here's your textbook. Here's the spreadsheet, and maybe I'll include the spreadsheet when I post this video so you guys can kind of take a look at how I did the math over here. But yeah, this was based on question number 4 from section 12.4. So let me know if you have any questions. All right, guys, take care. Good luck. And don't hesitate to reach out for help. Bye-bye.